I'm dealing with exponents right now. When I'm dealing with exponents, you can't deal with, the exponents are the little powers. I refer to them as little people. Not really little people, but like babies. Like if you're holding a baby, that's different. Babies are different, okay? And the reason why I say that is because I tell all my students, 5 times 4. Anybody could tell me what 5 times 4 is, right? 5 times 4 is 20. However, if I put this as an exponent, x to the 5 times x to the 4, you can no longer treat that as a big person. So this is an adult. The 5 and the 4, these are like big, I call them big daddies. Those are my adults. However, when I put it as a little exponent, they now become little babies, and you can't treat it the same way. So the rule for, you would multiply big daddies, but the rule for the little ones when they become babies is you have to add those powers together. So in this case, you would end up with x to the 9. That's just an example that's not on the paper. I just wanted to go through that before we did these two. Okay? So it says when I use the product rule, product means multiply. Product means multiply. I will add the exponents, which are the little babies of the same, as long as they have the same base. And you would still multiply the big daddies, which are the coefficients. Those are the big ones, the big numbers, the big daddies, okay? So let's do that. You have to know the difference. Are these big daddies or are these little babies? Those are little babies. So what do you do to the little babies? You add them, as long as they both have x's. So that's going to be 3 plus a negative 20, and that's negative 17. That's it. All right. Now over here, you have to notice I have some big daddies and some little babies, okay? So remember, with the big daddies, you treat those normally. 5 times 4 is 20. So big daddy, we got to multiply 2 times 5. That gives me a 10. However, the rule is not to continue to multiply these. The rule is to add them, because these are babies. We treat them differently. So, but only the x's can be added. 2 plus 3, that gives me a 5. Now, look at the y's. There's only one y. There's no other y's. So we just keep it. There's nothing to add to it. So that's my final answer for that one. All right. So just like we had that rule about the big daddies and the little daddies when you're multiplying, there's another rule. There's another rule when you are dividing. A lot of people forget what quotient means. Quotient means we are dividing. It's a division problem. So let me show you again. Basic thing is, most people, you could tell me 20 divided by 5. These are big numbers. These are the big daddies. 20 divided by 5 is a 4. But if I turn them into the little baby powers, you cannot treat them the same way. In this case, I got some on top and some on the bottom, which means I need to subtract. This is 20 minus 5, which will give me a 15. So I had to subtract the powers. But the big daddies, I treated them normally. I divided. So when I use the quotient, which is divide rule, I will subtract, and the exponents are the little babies. But the big daddies, or the big numbers, I should call them, or if you want to call them big mamas, that's your business, whatever you want to, you will actually divide the big ones. All right? So here we go right here. You have to understand, are these big daddies or are those little babies? These are little babies. So the rule for the little babies is to go ahead and subtract them. As long as they both have x's, that's fine. So that would be x to the, what's 15 take away 5? 15 take away 5, that would be 10. X to the 10. Now listen, because a lot of people think this, and when you write it like this, is the same thing. No, this is not the same. Okay, so don't write it like that. No, don't do that. Don't do that. Keep it like that. However, this one over here, notice we got some big daddies. And the big daddies usually always sit in the front. Kind of like when you have bigger people, you'll sit them in the front of the car. You put the babies in the back seat. So we got some big daddies in the front. And in this case, this is going to reduce. 20 and 30 will reduce. You can use your alpha y equals. Put your 20 on top and your 30 on the bottom. And it will tell you what it reduces to. 2 over 3. So I have 2 on top, 3 on the bottom. I just divided the big numbers. Now, remember, the little babies, treat them differently. I need to start subtracting the little babies. But you have to be careful because, okay, this one should be an easy subtraction because we're just doing 5 minus 3. So for the A's, I have a power of 2. However, this one here, be careful because people think, oh, this is just 7, take away 3. That's not right. This is actually 7 subtract a negative 3. And a lot of people remember what this means to do in the middle, but if you don't, that's where you get your calculator and you put a 7 subtract, that's a negative 3. And your calculator will help you come up with that answer because it really means I'm just adding everything, which is 10. So for the B's, that's a power of 10. Now with the C's, same thing. Be very careful because the top number is negative 15. Then I have to subtract whatever that bottom number is, which is negative 5. Now this one has a whole bunch of negatives and subtractions all over, but remember, that 15, that's a negative 15 on top. I got to subtract what's on the bottom, a negative 5. And that gives me C, these are for my C's, to the negative 10. All right. So this answer, it could look like this on the STAAR. This could be my final answer. However, there's a secret rule we didn't talk about, and that's when you have a negative exponent. So I'm not going to touch anything else because all the exponent, that was positive exponent, that was a positive exponent. But sometimes they will not leave a negative exponent. What they will do is they will take only this negative piece and they move it downstairs. Think of the fraction as upstairs and downstairs. They're going to move it downstairs where it will become a positive number. So technically, this is my final answer because you're not supposed to leave it negative, but sometimes on the STAAR, they will leave it negative. Okay? Put that right there just in case anybody needs to see it. Now we have our last rule, or actually our second to last rule, which is power to a power. This rule is kind of confusing for people because they think it's the same as the first rule we talked about, but let me show you the difference. So when we just have the little rules like a to the 5 and a to the 10, we would just go ahead and, oh, this is a multiplication problem. That would be a to the, add those up, a to the 15. However, now you're going to start seeing that we have an exponent, but there's another exponent hanging on the outside of the parentheses, which means I need to multiply the exponents together. So that would be a to the 50. Okay? So you see the difference how these ones, they both have their own a and their own power. But this one, there's only one a to the 5, and this power doesn't really have a base of a. It's kind of just like a power without a variable or a base or a letter. All right? So take a look here. When you see that power right on the outside of the parentheses, you're going to multiply it times anything else on the inside. So this will be y to the 18. Over here, this 1/2, I know it looks weird, but it is supposed to be a power of 1/2. So remember, we will, sorry, I forgot to write it in, we will multiply the exponents, but we will not multiply the big daddies or the coefficients in the front. What we actually have to do is try to figure out what is 64 to the power of 1/2. 64 to the power of 1 over 2 will give us and 8. So we start off with the 8 because that was my 64 to the power of a half. However, now I need to look at my k's. And for the k's, I do the same rule. Multiply the exponent. So 6 times 1/2. 6 times a half, if you don't believe me, is half of 6, which is 3. And then for the r's, 2 times a half, that's half of 2, which is invisible 1. So the invisible 1 probably won't be there if you're taking STAAR. It would just look like this. There will be no 1 right there because it will be invisible. Now the rule for negative exponents, we talked about it right here. If it's upstairs and it's negative, you move it to the bottom, you make it positive. If it's already downstairs, like this one right here is already downstairs, so basically I need to just move it to the top and it will become a positive 5. This one was upstairs already, so I move it to the bottom and it becomes a positive 5. But I have to leave an empty 1. Don't leave it empty. Put an invisible 1. Now this one over here, everything that's positive, leave it where it is. X to the 5 is upstairs, keep it there. X squared is downstairs, keep it there. Because it's all positive. The only one you need to move is the one that has the negative exponent. And right now, it's upstairs. So I need to move it down, and then it will become a positive exponent. Now, this is the last part because we're going to finish simplifying this one right here. Simplify. Let's finish simplifying it. So remember, if you have a fraction, you got some up here, some down here. We need to subtract the powers. So that will become 5 minus 2 is 3. However, down here, these are right next to each other, which means we would add those together. Even though they're downstairs, they're still next to each other, so we would add. Even if they were upstairs next to each other, we would add. So that's y to the 8. And this is my final answer. I cannot do anything extra to this because this has a base of x and this has a base of y. Remember, same base, you can do something. Same base, you can do something. Different bases, you stop. All right.